Hello everyone, my name is Yuchen Liu. I'm glad to present you a paper, Seeing is Believing and Predicting Context-Aware Multi-Human Behavior Prediction with VLMs. Starting from the motivation, we've seen many recent works of human behavior prediction mainly focus on egocentric single human scenarios, and that leads to a vacancy in spatial-temporal behavior prediction of multiple humans in third-person view, which is essential for mobile robot applications. It also lacks suitable datasets that match all the essential conditions, with multiple humans in third-person views and provide structured spatial-temporal context. And what we contribute to with this paper. Here we present CAMP-VLM, standing for Context-Aware Multi-Human Behavior Prediction with VLMs, which is a VLM-based prediction framework comprising visual observations, scene graphs, and scenarios with up to 3 humans. We combine supervised fine-tuning and direct preference optimization to enhance the prediction performance in a data-efficient way. Due to the lack of suitable datasets, we collected a synthetic and a real-world datasets with corresponding scene graphs on our own. With that, we could achieve up to 66.9% improvements in accuracy compared to the best-performing baseline. So what kind of problem do we solve here? As input, the system takes a sequence of RGB video frames, a scene graph, and a prediction prompt. The scene graph has a hierarchical tree or graph-like structure with multiple layers of nodes, standing for floors, rooms, and objects. Each node has its own attributes, such as the object states and the avoidable actions. An edge connects 2 nodes from different layers, indicating the semantic relationship, such as an object locates inside the room. The system outputs a set of future action labels of m humans up to a time horizon t. To realize this, we introduce a 2-stage fine-tuning process. The first stage uses supervised fine-tuning, SFT, for data-efficient learning, and the second stage uses direct preference optimization for preference alignment. For stage 1, we need to generate a SFT dataset. It comprises a set of ground truth input-output pairs, xi and yi. The input xi contains an image sequence, a scene graph, and a prediction prompt, and the output yi refers to the ground truth behavior labels. Now moving to stage 2. The purpose of having the DPO stage is because of the gains from SFT is often limited by the size of the dataset, and using DPO helps to avoid overfitting caused by small datasets and to bias the VLMs towards outputs with smaller character level deviations. Here we also need a preference dataset. The SFT reference model from a previous stage generates a batch of outputs. From them, using a similarity matrix such as edit distance, the preferred and the non-preferred responses can be selected based on the lowest and the highest ED values. For the evaluation, we collected the synthetic and the real-world dataset. The synthetic one is generated with the virtual home simulator, and the real one is recorded in the office area of Bosch Research Campus. And what we achieve with CAMP-VLM, we use Quint2 VO models, mainly the 72 building variant, and metrics like accuracy, cosine similarity, and edit distance. We compare our approach to 2 state-of-the-art baselines, CAP-MLM and NGPT. We trained our approach with the synthetic dataset and evaluated on both synthetic and real-world ones. In the end, we could achieve 66.9 higher accuracy than CAP and over 3 times more accurate than NGPT. To conclude the presentation, we present CAMP-VLM, Context-Aware Multi-Human Behavior Prediction with VLMs, which integrates temporal and contextual features from visual inputs and spatial relationships from scene graphs. We fine-tuned the model with SFT and DPO and achieved up to 66.9 improvements in accuracy compared to the best-performing baseline. In summary, we introduce a promising step towards scalable, third-person, multi-human behavior prediction in this work. As for challenges in future work, the current dataset scale is still quite limited, and the multi-agent interaction modeling can still be improved. We also wish to apply this prediction framework in downstream robot task planning approaches, and we are currently working on it, so stay tuned. That wraps up my presentation, and please feel free to scan the QR code for the project page for more details. Thank you for your attention.